Hello, welcome back to class. So yesterday we talked about how to find the area of any regular polygon, and we went through and we identified the different parts of a polygon. So we know what the side length is, we know what the apothem is, and we know what a radius is. And we were able to break down our polygons into several congruent triangles in which we were able to calculate the area of and then just multiply by however many triangles we had. Okay, so if you're looking at the pentagon, um, looking at the purple triangle, we were able to calculate the area of just one triangle, which is the one in purple. And we said that the base was the same thing as the side length of our polygon. The height of the purple triangle was the same as the apothem of our polygon, and then we would divide that by 2. Then we would just multiply that by the number of sides of our polygon, and that would give us the total area. So we ended up with these two equations where we have area equal to side times apothem times number of sides divided by 2, or the side and the number of sides, these two things when you multiply together, that's the same thing as the perimeter. So you can also just take the perimeter times apothem and then divide by 2. Okay, and then we went through some example problems where we had to first calculate the measure of the partial central angle. So here we have angle theta, and that was equal to 360 divided by 2 times the number of sides. So here is our formula for that, and that's going to work for all of them. And once you calculate that angle, then you focus on this bright green right triangle, and you use your SOHCAHTOA to solve for the pieces that you would need to be able to plug into the area formula. Okay, so for this pentagon, we had to first solve for the side length. And remember, the side length is equal to 2 times the length of this leg from the right triangle that we labeled as x. And once you get all your information, so here we solved for the side, which we ended up getting as 20 times tangent of 36. Then you plug it into the area formula, which was side apothem, number of sides divided by 2. And remember, we're aiming for 1 round off per problem, so we don't round off that side length. We just plug it in as is and then plug everything into our calculator and then get 1 round. Okay? So then after that, on the next page, we did an octagon. This time we had to find the side and the apothem. So you did a similar process, just solving for the side, and then we solved for the apothem. So for side we used sine, for the apothem we used cosine. And again, 1 round off per problem, so you plug everything in and round then in your final step. Okay, so the 3 that we're going to look at today are going to be special cases. And I say that they're special because the triangles involved will all be special triangles. And on all of these, I'm going to put a star by these so you guys know to that these are going to be treated as special. So the hexagon, the squares, and all equilateral triangles, I will want you to give me exact answers, so no decimal answers for these. Okay, so we're going to work through an example of each. Okay, so starting with the hexagon. Our hexagon, whenever we go and we sketch in our represented triangle, here we've got that. For a hexagon, if you were to drop down that apothem, and we are to look at just the right triangle that we've been using for the other examples, whenever you go and you measure or calculate this angle, that's going to equal 360 divided by 2 times the number of sides, so divided by 12. So that gives you a 30-degree angle. Okay, so now you might realize why I say that these are special. This bright green triangle that we have highlighted, that's a 30, 60, 90 triangle. So that means that we can find exact measurements for its sides. We don't have to use SOHCAHTOA. Okay, Well, in the original problem, they told us that our side length was 12. Okay, so if our side length is 12, that means that this side right here, my short leg, that's going to be half of that length, right? Because the side length is going to be the same thing as the radius, and the radius is the hypotenuse, so this leg right here, this short leg, is going to be half of that. So that's going to equal 6, which means my apothem is going to equal 6 radical 3. Okay, so it'll always be that the apothem is equal to half of the side times radical 3. Okay, so apothem 6 radical 3, and we have 6 sides. Okay, so now we have everything that we need to know to be able to find the area. So on these, there is no extra calculating. You're just using your special triangles. Okay, so now when we go to plug in for area, area is equal to side, apothem, number of sides, divided by 2. So when we plug in, we have 12 for our side. The apothem is 6 radical 3. We have 6 sides, and we're dividing that by 2. Okay, so then we simplify, and we end up with 216 times radical 3. So remember, you multiply numbers together, multiply radicals together. So 216 radical 3 would be your final answer for that area. Okay, our next special case is a square. So for a square, remember we actually have 3 formulas that we can use. You can use the new formula for regular polygons, which is the most work. The second formula you could use is the formula for the rhombus, diagonal 1 times diagonal 2 divided by 2, because a square is also a rhombus. Or you can just use area equals side squared. Okay, so depending on what they give you, that's going to determine which formula would be easiest. You probably want to avoid using our new formula because that will be the most work. So either use area equals diagonal 1 times diagonal 2 divided by 2, or area equals side squared. Okay, for this one, they gave us the apothem, and when we look at our represented triangle, if we calculate the angle we've been using for our other ones, half the central angle, that's going to equal 360 divided by 2 times 4, or 8, and that's going to equal 45 degrees. Okay, so this is a 45, 45, 90 triangle, which means that this leg right here is 4, which means that our whole side will be 8. Okay, so in this case, if they give us the apothem, it's very easy just to use area equals side squared. So then when we go and we solve, area equals 8 squared, so that is 64. Now on that same example, if they were to give you the radius, so let's say they gave you this side right here of the bright green triangle, that's the radius, you know that if you extend that through, that diagonal is just going to be double whatever that radius is. And the diagonals are equal in a square. So in that case, if they give you the radius, it would probably be easier to use the rhombus formula, diagonal 1 times diagonal 2 divided by 2. Okay, or just solve for the side. Okay, so then our third example is another equilateral triangle. Now, we have an equilateral triangle formula, which we learned about yesterday. That was the side squared times radical 3 over 4. Or you can use our new formula. So depending on what they give you. In this case, you're only having to plug in side if you use the equilateral triangle formula. So usually this is going to be the way to go. Unless they give you everything already and you don't have to calculate extra stuff, you want to use the equilateral triangle formula. Okay, so to do that, we just need to know what is the side length. So again, we'll look at our representative triangle. And we're going to need to compute half of the central angle. So that's going to be 360 divided by 2 times 3, or 6. And that gives us 60 degrees. Well, that means that this is a 30, 60, 90 triangle. And they have given us the short leg is 6. So that means that this other leg, the long leg, will be 6 radical 3. And that also means that your whole side is going to be double that 6 radical 3. So 12 radical 3. Because remember, the apothem cuts those into congruent pieces. Okay, so if they give you the apothem, that's pretty easy because that is the short leg that's across from the 30 degrees. Long leg, you multiply that by radical 3, and then you get the side length by doubling it. So our side is 12 radical 3. So all we have left to do now is to plug into our formula. Our side was 12 radical 3, and we're going to square that, times square root of 3 over 4. So squaring the radical expression, remember you square each number, so we get 12 squared times radical 3 squared is just 3 times the square root of 3, and that's all over 4. And then when you simplify, that gives us 144 times 3 divided by 4. That gives you 108. And then you still have the times radical 3. Okay, and then you would tack on whatever your units are after that. Okay, so those are your 3 special cases. If it's a hexagon, a square, or a triangle, you'll want to always use your special triangles to get your exact answer. Everything else, then you use your SOHCAHTOA and proceed as we did yesterday in class. Okay, so that is it for today. For the rest of this period, then you can go ahead and work in small groups on your homework for tonight, which is listed on your homework guide. And we'll see you tomorrow.